Hello and welcome to Learn with Swasti. Today in Math Pedagogy, we will be doing another very small topic which is often asked, and this is what are open-ended questions and close-ended questions. So let's begin. Now, when we are doing open-ended and close-ended questions, we will be doing this with respect to mathematics. However, please understand that open-ended and close-ended questions are a part of social sciences, is a part of taking surveys. It's a part of how you gauge what is it that the student knows or the surveyor knows. It's a part of surveying also. So for that, you need to understand. Now, while explaining, I will give you a lot of examples which are maybe not entirely mathematics based, but while we will be doing, when I show you these examples, when I discuss examples with you on the slides, they will be definitely mathematical questions because this is mostly asked in the maths paper in CTET. So we will learn what are open-ended and close-ended questions. We will do examples of the above, both non-maths and maths, and then we will take up one or two CTET questions and answer the same. So whenever we ask an open-ended question, the intention is that we want to understand how is the child or the respondent feeling on what are their views. They cannot be answered with a simple yes or no. So A, they are not yes or no questions. It cannot be, do you like coffee or do you like tea? So they have to say yes or no. The answer also should not be same. So it may not be a yes or no question. For example, if I say, what is your name? You will only give your name as an answer. So it doesn't involve you thinking. It doesn't involve your views. That is also, that will not be an open-ended question. Okay. So the answer cannot be the same. In this open-ended questions or through open-ended questions, we can understand what the learner's knowledge is. So if we want to know what is it that you think, and every learner will have a different different answer. It need not be the same. And there are many correct answers, so that there are no wrong answers. Okay, so that is what open-ended questions do. So for example, if in a survey, if I ask you, what what are your feelings about this book? Or what is your opinion about this book? Then I leave the question open to you. You can say, I like this book because, or I do not like this book, or I'm okay with it. So when you're doing these kind of questions where everybody has the space to answer what they know, that becomes an open-ended question. Okay? We'll come to the mathematical examples as per CTET later. So as opposed to open-ended questions, we have the close-ended questions, which are either answered with a yes or no, or they can be one-word answers, and all the respondents will give the same answer. So you can't have 2, 3 answers. It's like a question asking what is 2 plus 2, and everybody has to say 4. So that's and generally these questions are factual, and the main intention of close-ended question is to check factual knowledge. So we are not checking the learner's perspective out here. Let's go through a few examples. So if I'm asking open-ended questions, if I ask a child of 7th standard, what do you know about parallelograms? Tell me a few properties. Then I'm leaving it open, and as a teacher, I will come to know what is it that the child knows about parallelograms. Okay. Or if I say, give 2 numbers that add up to 15. Now I've not specified, just any 2 numbers. So 15, we can get 2 numbers to add up to 15 in infinite number of ways. So a child who only knows natural numbers might even then can say 14 plus 1, 13 plus 2. So there are many numbers. The child who has understood whole numbers can say 15 plus 0. Child who has understood integers can start using negative numbers. The child who has understood fractions and decimals. So just having a list of 2 numbers that add up to 15 would be an open-ended question, because as a teacher, I will have a reason to ask this question and figure out what is it that the child knows. Okay. Again, another open-ended question would be make a list of 5 prime numbers. So let me see how much the child understands prime numbers. Does the child really stick to 2, 3, 5, 7, and maybe 11, or can the child even give? I can make this question more tough by asking, give me 2-digit prime numbers, or give me make a list of 5 numbers, 5 prime numbers which are greater than 50. But everybody can come up with a different answer. So these are examples of open-ended questions I've taken from maths. Similarly, if I'm asking close-ended questions, if I say list all odd numbers between 1 and 9, both included. Now the set is finite. Everybody will give the same 1, 3, 5, 7, and 9. Or how many angles does a rectangle have? It has 4 angles. And it's a set of numbers from 15 to 20. So similarly, questions like these become close-ended questions. Ideally, we should use more open-ended questions because we want to gauge the child's perspective. Also, close-ended questions, if a child has, the child might have a tendency to rote memorize these things. So concept-based questions are mostly open-ended questions. Let's look at a few CTET examples. It has been asked, and I'm sure that once you've understood this concept, you can answer any question based on this. So which of the following is an open-ended question? That's generally what the question is. Which of the following is an open-ended? Which of the following is a close-ended? Which of the following is not an open-ended? So there could be various versions of it. Write numbers 25, 71, 19, 64, and 85 in ascending order. So there is only one way of writing it in ascending order. So this is a close-ended question. Which is more, 1/3 or 7 by 5? So 7 by 5 is more because it's a mixed number. It's an improper fraction, more than 1. So again, there can be only one question. Write any 4 numbers greater than 2.5. Okay, this is an open-ended question and I'll explain why. And what is 7 more than 2 by 7? So you just have to add 7 plus 2 by 7. Again, you will get the same number. But when I ask a child to write any 4 numbers greater than 2.7, the child can write any number, 3, 4, 5, 6, 2.71, 2.72, 2.73. So depending on how well the child has understood the concepts that you're teaching, write any 4 numbers greater than 2.7 will be a open-ended question. Let's see another question. Consider the following. 5 plus 3 is equal to question mark. The open-ended question corresponding to the above close-ended question is. So they've asked that there are 4 statements given and you want the open-ended question which corresponds to the above close-ended. So 5 plus 3 is equal to what, or what is 5 plus 3 is a close-ended question. So find the sum of 5 and 3, close-ended, because it is just find the sum of 5 and 3. What should be added to 5 to get 8? So here we've gone a little higher when we're talking about subtraction, but the answer still remains the same. What is the sum of 5 and 3? Which is the same as the find the sum of 5 and 3, just change the words. So that is also 8. But when I say give any 2 numbers whose sum is 8, you need not give 5 and 3. 4 plus 4 is also 8. 6 plus 2 is 8, minus 6 and plus 14 would be giving you 8. So there's many sets which can give you 8. So therefore, give any 2 numbers whose sum is 8 is a open-ended question. So thank you. I hope the concept was clear to you. And in case you've understood this, and if it was helpful, do like this video and share it.